how we can solve the hydrate formation? That is the question that we want to answer with this presentation. The first thing is to increase the temperature, because we have seen that if I increase the temperature, my operation point goes to the right of the curve, and we can see here again the chart. So as I told you, my truck site at high pressures, for instance 200 bar G. So I have, in terms of pressure, my point is around here, for instance, and my truck is around 35 bar G, is around 40 bar G. So my temperature is at this point of my chart. But once I am depressurizing the system, as I told you, happens two things. The first thing is that the pressure gets lower, so I move to this way, and the temperature gets lower also because the effect of the depressurization. And as fast as I do the depressurization, faster will be the release of energy, and faster I will decrease my temperature, and I will not have time to exchange heating with the ambient to try to compensate the energy losses. So my operation point goes down, it goes to the left, and once it goes to the left, it can reach the hydration point. If I increase the temperature of my system for any reason, for instance, we can add a preheater before the depressurization valve. Although I decrease the pressure, I can get my temperature above the hydration point. So I will be lowering my pressure, but I will not get near to the hydration point, and with that I will avoid the risk of having hydrates. But it is only possible when I am inside the skid, inside the depressurization system, because there I have space to add a preheater and something like that. But I cannot use this technique, let's say that, in the truck nozzle, because I will not heat up the truck. I need to work before adding the gas to the truck. So in order to do that, we need to remove water from our stream. And here I have the same, the first picture is related to the same one that we have seen before. So we can see here that this envelope represents a stream with around 2,700 ppm of water in molar basis. However, if I reduce the water content from my stream, the dehydration curve will go into the left. And here, just to compare, you can see that it was the original point, and it was far from the red line, and now the new hydration curve based on this content of water in ppm volume is very near to the red line, and this point here, it represents around minus, able to reduce the water content enough to have hydrate formation around minus 2 Celsius degree. For me, it's perfect, because according to my operations, I have seen that the minimum operating temperature was around 15 Celsius degrees. So I will be safer in my operating conditions. I will not lose production. I will not reduce my production, and that is what the companies wants to. And to remove the water, I have many kinds of technologies, so that's why I needed to do the research.